Hello, welcome for our series of science lessons. We have been looking at the Earth's fragile crust, and we are going to look today at geological time. And before we come to look at the geological time, in the previous lessons, just to make a review, we were been able to look at the landscaping crust, looking at the earthquakes, volcanoes, and their effects on the earth crust. Today, as we are able to go through this part of the geological time, is actually a glimpse that we'll be able to understand various changes that have been taking place throughout on planet Earth. For a long time, people have wondered about how the Earth is actually changing since it began. And they have been asking themselves, how are these events coordinating and how are they happening? Do we have a period, or do we have an evidence to trace back where it began and where it has undergone the changes? That brings us to this lesson that we'll go through geological time for us to be able to understand some few concepts. Tracing back to the biblical records, it is believed the earth was created, that is around 4004 BCE, making the planet Earth to have existed or to have been in existence to about 6,000 years old. Therefore, that is the biblical record shows that the earth has been on existence about 6,000 years old. That is about the earth. What about the scientists? We'll be able to look at the geological period as we are able to understand various scientists coming up with various ways of determining the ages. Actually, when you are on planet Earth, you'll be able to find various changes happening. For example, in the field of plants, plants grow and it reaches a time, they mature, then they die. After dying, they leave behind some seeds. Actually, when you look on the big trees or some just relatively some plants, especially the grown-up trees that actually have been surviving for a longer period, around 50 to 100 years, there has been an exercise. Actually, that is, there is a growth ring. There is a growth ring. When you look at those trees very careful, there are growth rings around the tree. When you study careful, you may be able to trace back the time this tree began to live. Because this type of tree have some rings on it. Those rings, when you intersect the tree, just in a transverse manner, you'll be able to find out various types of rings with different colors or maybe with different marks. And these rings, these are what we call the growth rings. These growth rings, beginning from the first one, you will be able to come up with or we are able to determine the age of a particular tree if it has existed severally or for several years. This is the ancient method people could be able to use, especially determining the age of plants such as trees. The best way they were observing and studying the rings, we call them the growth rings around the tree. Actually, this ring is actually a laminae that represent various years. For example, such a ring from the first to the last ring, this ring can be able to around in existence, or it forms after a period of 10 years. Therefore, if you want to determine the number of the age of this tree, we can count these rings up to the first one. And as you go, the inner rings becomes thick and thicker, giving a precise age of a rock. Therefore, if you are able to look at that, we can easily able to tell the number of years or the age the tree has been in existence. But that one will not tell us all about the age of the earth. That is only about the plants. To the human beings, we are able to know, and even the animals. But what about the fragile earth crust? Or what about the planet Earth? People have been wondering how the earth is estimated. In a more recent record, the scientists have estimated the ages of rocks, and that is, in the study of rock, we have what we call geologists. Geologists are the scientists who study the rocks and even the minerals. And it is up to them that we are able to come up. Actually, when you study also the rocks by a scientific method, we are now able to come up with the geological time of the rocks. Remember, in the previous lesson, we were able to look at the formation of various rocks, how rocks are formed, finding out their characteristics. Though we'll be able to look at it in a more specific way, how to identify some of those rocks in later lesson, but we learned about how these rocks are formed. For example, the igneous rocks. Geological time is told by geologists, they were able to come up with a way of estimating the period or the age of rocks. And that age of rocks scientifically have been able to determine. Now these are the scientists have come up with a geological time by studying the layers of rocks. Because an example of the layers of rocks, especially the sedimentary rocks, when we look at the sedimentary rocks, most of these rocks, they are actually laid down in strata. Therefore, in the process, they are stratified and lithified. That process of being lithified, it actually caused the rock to be found by the geologists, and then they are able to determine the geological time or period over which certain rock has been in existence. And that one is possible to tell us from the beginning. When we look at the earth structure, it's able to tell us that actually if rocks have been able to exist for a certain period of time, scientifically, or the geologists have been able to determine the age of rocks, and that gives us the age of the earth to be having existence to be around, that is 4.5 to 5.7 billion years old. These are the scientific estimates that have been able to come up by the scientists trying to give us the billion of years that the earth has been in existence. But how is it possible? The geologists came up with what we call geological timescale, which is a system of the chronological dating that relates to geological strata and time. That is what we are going to be able to look at. How was it possible and how was it made? So that they came up with the various eras of geological period. Basing on the chronological system and dating of geology, especially basing on the strata to time, this method was used by the scientists such as paleontologists, geologists, and other scientists who are still doing geological and geomorphology study. They are able to speak in the same manner. And this gives us back to the story of fossils. When we look at fossils, that is where all the origin begin. Because what do geologists do? What do paleontologists do? Paleontologists study what we call the fossils. And the story of life on Earth is told by the fossils it contains. Therefore, paleontology becomes a branch. We have it, paleontology. Becomes a branch of geology that studies the fossils. Therefore, it is the paleontologists who are coming up from what we call geology, the school of geology, that are able to study the fossils. When they are studying the fossils, they are able to tell us how these fossils were formed, under which condition, under what circumstances, and what happened after that. Then they give us a determining geological period that we are able to rely on from scientific point of view. Anyway, in the previous lesson, we looked at fossils. Then what are fossils? What are the fossils? Just to remind us, we were able to find out that fossils are the remains of the ones, living organisms, who died and were buried in the soil. Some of these fossils, they are found especially in rocks, which are made up of hard parts of animals. And those hard parts of animals, they include bones. We have shells. Some of the hardest part we call them the exoskeleton and chitin. These are the hard parts that is made up of the animals, the ones living organisms who lived a period of time and they died. After them dying, they were buried in the soil. Remember, when they were buried in the soil, there's a process called lithification, or they were deposited in strata. And then after being cemented together and being compacted, that is the process of rock formation, they were lithified, and then we came up with what we call fossils. And we were able also to look in a higher level. We'll be able to look at the fossils as a source of, we have been able to look at the fossils as a source of energy, and we are happy to identify that it is from the study of fossils that we are able to find out the period of geological time. How are these fossils formed? Just to remind ourselves, because we had already done this part, fossils are formed under specialized conditions. There are various conditions under which fossils are formed. And one is the rapid and permanent burial. When an organism dies, there should be rapid and permanent burial. When an organism dies, it is permanently buried. And when it is buried, the specimen is protected from environmental and biological disturbances. In so doing, scientifically, we are depriving oxygen from them. And as a result of that, they will undergo what we call a certain process. That is one of the conditions over which fossils are formed. The second condition, how fossils are formed, the organisms or the organism that is there should have remained longer time. The organisms should remain buried for a long time, should not be interfered with. They should remain buried. That is for a long time. When these organisms remains buried for a long period of time, what is specifically denied here is excessive heat. We are trying to avoid excessive heating from this organism. Therefore, to allow compression, or to avoid compression which may destroy the whole hard parts of that animal. And therefore, the last condition, that is now compaction of the fossils. When an organism has been buried, it has remained for a long period of time. Therefore, it is compacted. That organism is compacted. That fossils is compacted. This occurs to make it undergo what we call fossilization. It is compacted to undergo what we call fossiliated. It is now fossiliated in the process, and it is now embedded into the rocks laminae or the rock strata, and this becomes the fossils. That is how fossils are formed. They are actually formed under these three conditions, and we'll be able to find out there are also various kind of fossils. That one is for the next lesson, when we'll be able to look. Therefore, having looked at the fossils and how they are formed, there are more information that will be brought to the limelight as a result of studying the fossils. For example, the footprint of a dinosaur were found in the Queensland, where now we center on the study of the fossils. Be able to identify that the footprint of a dinosaur which have been found in the Queensland have been dated around 100 million years old. Because of that, it is as a result of the study of the fossils. That one is the footprint of a dinosaur. And right now, a dinosaur is an extinct animal, cannot be easily be found, but it was found during a given period of time when paleontologists study its fossils, and they found it in the land of Queensland. And when it was brought to the dating of the geological period, it was identified to have survived or to have been in existence around 100 million years old. How possible was it? How possible was it to have found such a scenario? This brings to us, for us to be able to find out the geological period or geological time. From scientific point of view, there are various methods which have been used in actually dating the fossils. There are various methods that have been used in dating of fossils. We are going to look these very few methods scientifically, and then these methods are the one that made it possible for various scientists to be able to estimate or to date back, for example, the footprint of a dinosaur and even other organisms that have been able to be studied in fossils. Therefore, there are two major methods of dating the fossils. One is relative dating. We have relative dating. This is a method that is used scientifically to estimate or to date the fossils. If we identify a fossil right now, we will subject them first of all to relative dating. And the major fossils have been dated actually in various parts of the world using relative dating technique. This is a method that involves what we call the relative. We call it relative dating. When the relative dating technique has been used, this involves actually comparing something for which its age is already known. For instance, if you have a fossil such as trilobite. Trilobite is a fossil. We always name the fossil according to what elements that they have. For example, if you have a fossil such as trilobite and it was found, this trilobite was found in Wheeler Formation during the Wheeler's Formation. During that formation period, the Wheeler Formation has been estimated that is to have been in existence approximately 507. That is 507 million years. That is from Wheeler's Formation. That means when we subject the fossil known as trilobite, we'll be able to find it during the period of the Wheeler's Formation, and the Wheeler's Formation gives us information about that it has been in existence for around 507 million years ago. Therefore, the trilobite as a fossils, we will be able now to say that the trilobite is also about, or the trilobite is about 507, that is million years old. That is what we refer to it as a relative dating. And in most cases, the scientists are using certain also methods, certain types of fossils to come up with the age or with the geological age of a given fossil. For example, most cases when they are studying the ages of rocks, they use certain type of fossils which is referred to as index fossil. as they use the index fossils, it assists them in relative dating, and actually the index fossils are the short-lived fossils. They have been found to have lived a shorter period than any other. Therefore, some of its laminae are subjected to index fossils and then brought in the limelight of relative dating. And sometimes when we look at the edges of rocks, there are some layers of rocks that can be studied to give us very useful information, since when we are able to go back to the rock formation, especially the sedimentary rocks, these rocks, we've been able to have found them, they are always laid down in strata. Therefore, they are stratified in layers, after which they have been deposited in a sequence. Those layers are lithified and compacted to form fossils. When we study the layers of those rocks and subject them to what we call the relative dating, then we'll be able to come up with a certain period. Now, the index fossils been able to find out that this is a short-lived fossils that have been in existence, not for a longer period of time. That is much more about the relative dating. We relate the age of a well-known substance or something, and then relating it with something that is with a fossil that we have not been able to know its age, and then we'll be able to determine scientifically. That is what we refer to it as a relative dating. We have another method that is referred to as absolute dating. Absolute dating is the kind of dating that is used to determine precisely the age of a rock or a fossils through radiometric dating. What do they use? They use what we call radiometric dating. And this is more accurate. This one will prepare us to go and also look at what we call the radioactive elements and radioactivity in our science lesson. But now, absolute dating uses radioactive minerals that occur especially in rocks and also fossils, almost like geological clock. Anyway, there is a geological clock that is able to subject a number of fossils. When we subject them to what we call geological clock, it is given a format of a geological scale. That is what we refer to it as a geological scale. It is a system of clock, just like a clock that we do put on, but that one is partitioned into eras and periods. Mostly the atoms which are found on Earth crust, they have what we call some elements. We were able to look at various elements such as minerals, and from that subject of minerals, we are able to find out different minerals have different chemical compositions, and therefore they are also distinct into definite shape. When we find some of these elements and substances, they are still found on Earth crust. They are made up of atoms. Some of these minerals or elements, they have small atoms that have chemical elements. These chemical elements, we refer to them isotopes. The chemical elements that are referred to as isotopes. And the isotope, when we look at this isotope over a period of time, most of them, they break down at a constant rate. When we study closely these isotopes, they break down at a very constant rate. That rate is what we call the radioactive decay. The radioactive decay. That is what we are going to find in absolute dating. And I want to make a statement here. The elements referred to as isotopes, they always break down at a constant rate. Through radioactive decay. Now, most of these isotopes, they are found in different elements or different minerals that are found on Earth crust. And by measuring the ratio of the amount of the parent isotope and also the amount of the daughter isotope that breaks into certain age, we are able to find their age accurately. And this will bring us to have been able to determine the radioactive decay. And actually the radioactive decay, radioactive decay is determined. Radioactive decay is determined in our half-life. That is a half-life of a given substance. When we are looking at the radioactivity, we'll be able to come up on radioactive decay. And when we are looking at the radioactive decay, we'll be able to look at a half-life. That is a more accurate, that is now the radiometric dating over which we have to find. Then what is a half-life? A half-life is the time that is taken by a radioactive substance to reduce its mass by a half. That is very simple. A half-life is the time taken by the radioactive substances to reduce its mass by a half. For example, there are various substances that are referred to as radioactive. For example, we have uranium is a radioactive substance. We have thorium. And then we also have tritanium or tritium, yes. Tritium, these are an example of the radioactive substances. All of them undergo what we call radioactive decay. Therefore, they form substances that always reduce into the number of their masses, and therefore leading to the formation of a new substance. Uranium, thorium, and tritium are some of the elements that can be found on Earth crust, although in rare cases. Therefore, we'll be able to look at them shortly, that is in the radioactivity. For example, when we are subjecting them at various radioactivity. There are 3 elements that are produced. These particles are the ones that undergo, that are formed, and one is the alpha. The alpha particle. And then we also have the beta particle. These were identified by the Greek. And then we have the gamma particle. These are important particles when we'll be able to look at the alpha, beta, and the gamma rays. When we'll be able to look at the X-rays, we'll have to identify the beta particles, the alpha particles. They are able to penetrate through some of the elements we are talking about. For example, let us look at this question that will help us to determine a certain half-life of a given substance. How many years will it take for 88 grams, that is, of tritium? How many years will it take for 88 grams of tritium to decay? To decay to an 11. That is 11.0 grams. And a half-life, they have given us a half-life of tritium. That is 12.3. This is an example of a question that we may be able to work out through when we'll be looking at the absolute dating. How many years will it take for 88 grams of tritium to decay to 11.0 grams? Given that a half-life of tritium is 12.3 years, we are going to work out arithmetically here shortly. First of all, we'll have to find out that tritium is found in the half-life of a given number. Therefore, we'll have to take 11 grams, and then we divide them by 88.0 grams, and then we equate it with 0.125. After doing that, then we know this is the formula of the half-life. Will give us this, that is 0.125. This is the number of years that we are going to look at. What are we supposed to do here? We have to check on this equation. Then we will say it is n log 0.5 is equal to, we also introduce the log on the other side, 0.125. Then we want to find the number of n. We'll have to take to take the log of both sides, and that is log 0.125. We divide it by 0.5, and then we'll be able to get, when we use our calculator, then we'll have to identify our number of n is 3 years, is 3. That is a constant rate. And then we have to find out if the half-life of tritium is 12.3 years. We are going to multiply, that is 12.3 by 3. And then we'll be able to get around, it is almost 36.9 years. This is, we have been able to answer this question. How long will it take for 8 grams of tritium take to decay so as it reduces in its mass to 11.0 grams? With this and more other examples, we'll be able to find this is what happens in radiometric dating. We have to take out arithmetic solution, and this gives us more accurate method of dating fossils. Having looked at this, we are going to look at many other in what we call radioactivity series. This is how the radiometric dating is done under absolute dating. We have been able to find out that some of the elements that are found on Earth crust have the special elements such as isotopes, and these isotopes are in a constant rate of breaking down through what we call radioactive decay. And when we measure the amount of the ratio of the parent and the ratio that is found in the daughter isotope that breaks out in a given period of time, we can be able to determine the age of that element. This is the method that we refer to it as absolute dating. Therefore, we look at there are various rocks. Most of the rocks contain substances that actually they gradually decay into other substances over a given period of time. For example, uranium, we've been able to find out that uranium decays over a given period of time, and it changes into lead. When uranium decays, uranium changes into a new element that is referred to as lead. This is its chemical symbol. For a period of time, therefore, uranium will undergo what we call radioactive decay, and as it undergoes that, it changes into a new substance or a new element that is such as a lead, and a lead is an example of a metal that is able to be extracted or can be able to be found. Now, therefore, by comparing the amount of uranium and that amount of isotopes that are found in uranium and lead in some given rocks, the age of that rock can easily be determined. For example, when we look at uranium, this is uranium in a given mass of rock. When uranium undergoes what we call decay, Therefore, we'll have uranium reducing and then the element of lead adding up. Therefore, when you compare, look at this ratio and this ratio, you'll be able to find out that this represents the parent isotope and this is the daughter isotope. Therefore, we have to look at the ratio of the parent isotope and then compare at the ratio of the daughter isotope. When we compare these both ratios and then we come up with an age to determine either the original parent, if we have the ratio of the original parent of a given isotope, and then leading after decaying completely, we will have a new substance that is completely having what you call lead element. In various completely, and will have a fully leaded component. Therefore, this parent has undergone decay to form what you call a daughter isotope. And then over a given period of time, the decay continues because it is constantly on a given rate, and then it will lead to the formation, it will change into what you call lead as an element. Therefore, by looking at this comparison, the geological timescale gives us a model which is always used by geologists, and it has divided actually the Earth's history into series of time interval. When we look at the geologists, they have come up with geological timescale. And the geological timescale is a model over which geologists have divided the Earth's historical events, the history of the Earth, and what makes the history is some of the events that have been happening and have been recorded. And these events have been able to divide the Earth into series, of time intervals. That is, we are now advancing at what we call the absolute dating, and therefore this gives us, as geologists, to come up with what we call geological timescale, whereby we are going to look at the history of the events that have happened on planet Earth, and then these events have been divided into series of time intervals. That time interval is what we call the geological time. Therefore, geological time is divided using significance events in the history of the Earth. For example, there's a boundary between the Permian and Triassic, which is marked by the global extinction, in which plants and animal species were eliminated. That is, we will say that they have been extinct. Now, during also the Precambrian period, the Paleozoic region or the Paleozoic era is marked by the first appearance of the animals with the hard parts. When we'll be able to look at the chart, then we are able to confirm all those geological period. Let us be able to study at our geological time that has been provided in a scientific chart so as we are able to study it very careful and then come up with conclusive understanding of the geological period or geological time, and this will bring us that we be able to look at the chart. When we look at the geological period, it has been subdivided into various historical events that have ever happened on planet Earth. Basically, there are periods that have been categorized in era, and then this is the period and the kind of life that was existing there. And then when we look at this far end, it is the million years that part of life has been in existence. Therefore, historically, this is what make what we call geological period. And there are main eras that can be counted in geological period. We have the Conzoic period, and then Mesozoic period era. These are Conzoic era, the Mesozoic era, the Paleozoic era, and the last one is the Precambrian era. The Conzoic era is divided into two periods. We have the Quaternary period and the Tertiary period. What kind of life was existing? Here we'll find that it was the human life, where it was made up of the Homo sapien. This is where the Homo sapien, and the Homo sapien is an intelligent man, where we find that this kind of life, of human life, has been in existence in between 0 and 2 million years ago. And the Tertiary period, this is now where mammals became so much dominant. And the type of mammals we are talking about here is now the dinosaur and the kangaroo. Those are the two periods over which the type of life were. And this is more recent era or the period of the geological period. As we ascend down, this takes longer years. When we come to the Mesozoic era, it is divided into two. We have the Jurassic period and the Cretaceous period. During the Jurassic period, the kind of life that was existing, it was a final period for the dinosaurs. We'll be able to have found that out that the dinosaur existed around 65 million years up to 144. That is a range between, and it became extinct. And then Cretaceous period, we have flora and fauna. Flora and fauna also existed in the in this age bracket, that is 144 million to 208 million years, where we also had the flying reptiles. When we come to the Paleozoic era is divided into 6 periods. We have the Permian period, we also have the Carboniferous period, the Devonian period, Silurian, Ordovician, and the Cambrian period, before we go to the Precambrian, that is the last or the ancient age. During the Permian period, their modern insects were identified, and their fossils have been dated to have lived between 248 to 290 million years ago. When we come to the Carboniferous, this is where the reptiles have been evolving, and this existed in between 290 to 362 million years ago. The Devonian period is made up of the amphibians. The kind of life that was existing is the amphibians. Amphibians now were coming up, and that was an existence in between 408 to 438 million years ago. The Silurian period comprises of the what we call the fish, corals, and mollusks. These existed in between 438 to 505 million years. And then the last period of the Paleozoic is the Cambrian, where we had the first vertebrae to be found. Therefore, after this, we'll be able to look at the next one. That is the Precambrian, where it had also composed of various ages of time. Coming to this brings us to a summary text of a geological period, or the geological time of what has been happening. Thank you for today. In the next lesson, we shall be exploring more on geological period and then radioactivity. Thank you.